Jackson or any kind of office that we have. But
good? All right. Okay, everybody, we're gonna get started. Thanks for coming. Imagine some people will file in slowly over time. My name is Jim Stevens. I'm chair of the Department of Architecture here at Lawrence Tech. So welcome to everybody here and streaming online and who will probably watch it afterwards. We're finding actually that our lecture series gets quite a bit of views afterwards, so we're happy about that. I'm also saying it to remind all of the students to tell your friends that maybe couldn't make it, they can watch it after the fact, or if you hear something tonight that maybe you were not able to note as accurately as that you wished, you can kind of go back and view it online and pick up that information. So tonight, I'm only going to talk really quickly. We're doing a BIM roundtable, so we're going to have a brief introduction with some information, and then we're going to spend some time having our local experts here talking about the use of BIM within practice, and more importantly, for those of you, the students here tonight who are starting to use this not only in studio but in other classes and potentially in your internships, this gives you an opportunity to ask questions within context. So tonight, Kristen Smith, who some of you guys know, who teaches in our visual communication system, is a professor of practice here within the college, is going to moderate the session for us. And we have Tony Pandush and Zubi, who I'll let her introduce in more detail, who have agreed to participate in the panel. And it's kind of a great moment for me specifically because all of them at some point or another had me as a faculty member either once or more than once. So this is a really great case of role reversal where now they're the teachers and I'm going to be sitting in the crowd learning. So it's a really great moment for the college and me personally. So with that, I'm going to hand this over to Kristen, who's going to introduce them and get us started. So thank you.
Thanks. So I'm going to give just a quick introduction to give some context to this talk. As Jim mentioned, I'm a professor of practice here at LTU, and one of the courses I teach is called Visual Communication. And in preparation for this event, I was looking at the work of our panelists and thinking about BIM technology and data-driven technology in the context of some of the ideas and theories that we discuss in VisCom. So I'm going to kind of bring the theory here for a minute, and then our panelists will bring the practice, and we'll go that way. So VisCom courses at LTU are rooted in the idea that representation, drawing, models, whether physical or digital, have the potential to be what Bernard Tschumi calls operative, in that they are devices which drive ideas and also take a position, and what Stan Allen calls transitive. Sorry, I've got a little. Neither an ends in themselves, nor simply technical instruments, but capable of producing something new from something else. And we also emphasize awareness of instrumentality, the way in which tools and techniques influence design processes, design thinking, and ultimately the physical world. While historically drawing methods have sought to represent three-dimensional and/or dynamic space, static representations primarily give us a static understanding of a building or of built form. And the attached image, or the image that I'm showing, which is from Bernard Tschumi book Red is Not a Color, the project notation on fireworks, where he's trying to, through 2D representation, capture ideas about time and spatial information in a two-dimensional notation. But the text on the book, paired with this, I think, reveals something that anyone who is in practice it resonates with and is familiar with. And he says, you think that both the scheme and the notation you developed are actually quite beautiful, so you go to show the fireworks fabricators your plans. The fabricator looks at you as if you are insane. And I think that's just something that we all sort of deal with in practice, is trying to translate drawing to building and use our drawings towards that end. And so in the book Architecture Practice, Technique and Representation, Stan Allen notes that far from being an ideal construction, representation is marked by contact with a messy and inconsistent reality. BIM technology, data-driven technology, and information gathering tools now allow us to not just visualize, but understand building as a system, one that is created and sustained by processes, performances, and ever-changing relationships between building and user, and building and environment. So our prior representation, understanding of representation is that it acts at a particular distance from built form. But new technology that we're going to talk about today, like digital twins and reality capture, begin to close that gap. And we see the industry moving from the singular static translation from drawing to building towards a more dynamic, continual oscillation between representation and reality. I was reading a design intelligence interview with Philip Bernstein on technology and the future of design, and he notes, where CAD mechanized the means of representation, BIM creates a formal knowledge structure that organizes the enormous array of digital data piles and processes that are becoming part of practices. Or, put another way, through the history theory lens of Mario Carpo, who writes, the first digital turn in architecture changed our way of making, and the second changes our ways of thinking. So when we look at the work of our panelists and the cutting edge technology in the industry, I think it's important to see through things like BIM, simulation and optimization, and other data-driven technologies as more than just cool software tools, and they are that, I'll give you that. But beyond that, they're changing our relationship to representation, which also ultimately changes the way that we think about design and about building. So with that, I'd like to introduce our panelists. They'll each, Tony's going to present some work, and then we'll have a few discussion questions and open it up to questions from the audience. So Tony Sabat is a consultant, advisor, and writer in the AEC built world industries, focusing on innovative and disruptive technologies and processes. He specializes in workflow technology, integration, and implementation. Tony has experience in many industry roles, including a survey engineer, general contractor in construction, and consultant. He's a graduate from Lawrence Tech University, as Jim mentioned, with degrees in civil engineering and architecture. And Tony says that he leveraged his knowledge at Lawrence Tech to push technology forward in the industry and establish for himself a role exploring how technology tools and techniques can impact our built environment, which is great, right on topic of what we want to talk about today. Pandash Gachi and Zubi Ononye come to us from Inform Studio. Pandash is a licensed architect working in the architecture discipline with expertise in digital fabrication, skilled in BIM, various 3D modeling softwares, project management, furniture design and making, and sustainability and innovation through computational applications. And Zubi is a design technologist at Inform Studio with an interest in computational building information, modeling design, digital fabrication, data wrangling, and data-driven processes to enhance the capabilities of designers, ensure efficient delivery of projects, and engage clients with data that provide insight about their projects through their life cycle. So I'll turn it over to Tony.
Okay. All right. Can everybody hear me okay? Yeah? So far? I like that last term for Zubi's, data wrangler.
Data wrangler.
I like that. I think that's pretty relevant to today. Yeah, here you go. A horse named Data or something like that. Alrighty. So thank you, Kristen. Thank you guys so much for the time. Really appreciate it. It's great to be back to reconnect with professors and students and learn what everybody's doing and where kind of the industry is evolving. Today we'll really be talking about how data is driving our design because of all the amounts and methods of data that we're really compiling and trying to sort through and understand, and how this is then also changing our role as architects, as designers, and how we can bring those into actionable insights. So let's try that one more time. Oops. Sorry about that. I think it's pretty similar, actually, but we talked a lot about me. I just wanted to touch on the workflow vetting and the implementation towards the bottom. That's the workflow vetting is really the easy part of our jobs, is understanding that this solution, this tool can really bring a lot of help and can bring a lot of value add to our clients. It's really the implementation that's the difficult part, and how you can scale those technologies into the organizations. And that's what we spend most of our day-to-day on, about how we can get this tool into this person's hands and start to run with it. And then innovation and technology, I like to talk about them a little bit separately, but I think they can almost be interchanged, and that's where I'd like to really begin talking today. Technology and the industry are often seen as separate entities that only relate or only talk to each other when they want to, or when they're supposed to, I guess. Our industries really haven't changed too much in the physical aspects of them. We're building bigger structures, and we're building more connected infrastructure, but they're pretty stagnant and pretty, I would say, have plateaued with their kind of utilization and evolution. But what is changing much more is the technology and the integrations that we can potentially utilize, and then also the innovative workflows that we can begin to look at also. I think if everybody's familiar with the McKinsey report that really touted or kind of shed light on the lack of productivity in the construction industry versus the automotive industry, one thing it points really to is that lack of automation, lack of technology integration. And I think our industry is different, but at some point it is kind of true as well. We've seen construction very resistant to any kind of technology because we've already done it this way. We know how to do it this way. Let's keep doing it this way, kind of thing. And we've seen technology integration almost as a separate entity that we don't need that fancy internet stuff. We don't need that fancy CAD stuff. We already know how to do it this way. And where I'd like to argue is that the technology portion of the industry really, it may be separate from the industry, but I see it as actually controlling the pace of the industry and actually representing the lever, the massive lever that can shift how our industry is utilized and how our industry can ultimately scale. So when you can control the scale of the industry, you can ultimately control the industry with how many housing crises we're looking at with people who need housing, coming up with all the couple billion people that are going to be coming into this world pretty soon, the overpopulation we have around the world, the way that we can utilize different technologies, different workflows to expedite those processes and maintain and keep up with the scale of our population, the better off we are. I chose this slide for my next point because it kind of shows that we have kind of two competing worlds where we have the physical, we've established how the physical works, and we really haven't touched how the digital can really help us or how it can integrate. I look at the analogy of we still use hammers, we still use nails, we still use screwdrivers, we've upped it to power drills, we've upped it to all these different technologies, but now we're seeing information and data and the iPad ultimately bringing all that information and putting it into every single person's hand that's involved on these projects as the next tool, the next workflow that we can begin to integrate. When we can show, take our information, take our data, not only from the designer or to the client or to the general contractor, we can put it into the subcontractor's hands. They can really begin to see everything we're trying to communicate to them much easier. And I think that's really what we'll talk about is this data is a communication tool where we talk with the client, they have this vision, and they're trying to communicate it to the architect, the designer, and then they're trying to communicate it then through all this whole ecosystem of stakeholders. How can we best do that? So I think everybody's familiar with a lot of the buzzwords that we have in the industry nowadays with augmented reality and virtual reality and generative design, parametric design, BIM, VDC. There's so many different opportunities we have for potential integration. With that McKinsey report that's really pushed Silicon Valley and looking at our industry as the next one ripe for disruption. It's a multi-trillion-dollar industry. That's a lot of revenue to be had. So let's throw every single solution we can at it and see what happens, kind of mentality. So it's really about understanding which solutions we can utilize to leverage value add for ourselves internally. That'll then translate to our clients or just directly saving the clients any time, trouble, and money as well when we can integrate any of these solutions. So today I'll talk about just a couple solutions. I don't want to hog the mic all night, but just to kind of give us a little idea of what technology is out there and then get some discussion going. So I want to start with reality capture. How many people are familiar with reality capture or laser scanning or point clouds? A little bit? That's all right. That's better than I thought. So that's pretty good. Think of reality capture really as the new face for these as-builts or quantifying our existing conditions. We're used to, the tape measure. We're used to the laser level. We're used to traditional surveying if you're in the engineering field. This really only gets a fraction of what is, potentially out there, capturing reality and everything that we see within it. So this next image is, some people who aren't familiar may think it's just a photo, but it's actually what's called a point cloud, which is a series of millions of points that together create a three-dimensional environment that is measured off of, extracted off of, and this can then have incredible amounts of detail with the scale of this, just the reality capture industry itself. I think it's a really great image because it shows just the detail in the rocks that you're seeing. You're seeing the deviations in the archways there. You're seeing snow in between the joists, or the joints between each rock. You're even seeing footprints, and you're actually getting a little bit of logistical information there to know how many people use this footpath here or here. So some of this data is so detailed that it's almost getting to sub-millimeter accuracy, where you can begin to set up a scanner within this room and capture the whole room down to the millimeter for each individual piece that's involved with this. So it really began with the surveying industry, I would say, where a lot of these guys call them gizmologists, where they were kind of tinkering with these lasers, and they had this laser that could shoot out at a building corner and bounce back, and when it would, that time of return for that laser would get back to the machine would then equate to a measurement. So based on how fast that light is moving and how long it took, will give you a measurement. And so from wherever that scanner is set up at, is going to tell you what that dimension is. And so this technology is also known as LiDAR, light detection and ranging. And the initial kind of, I would say, grab for the reality capture industry was more accuracy, farther range, and potentially quicker scan times, easier to scan. So some of the technologies that just came out recently, they're able to scan almost a mile and get sub-centimeter accuracy with these laser scanners. But you have to sit there and watch this thing scan for about 20 minutes to get that data. So this data has really proven itself as incredibly effective and just giving you that multitude of data that you're not used to. And I think this is a good first example of how we've been just bombarded with so much data in our industry too. How do we grab this data, make actionable insights off of it, and then kind of regurgitate it out for putting something into production? It's even really brought into question some of our concepts like floor flatness, and I should have put air quotes on that because it's not actually flat. With how detailed and dense this data can get, we're seeing the deviations in the floors and where they're going to start having issues here, or potential predictions for where cracks will develop. Even with looking at when we represent where a floor meets a wall or where a wall meets a ceiling, we're assuming that that's a 90-degree angle. We're assuming that from this intersection to this intersection, that is a straight line. And we know that when we can scan these after the fact they're built, they're not actually represented that way. And we know that this is gypboard that's got certain paint, it's got a certain texture on it, or different soundproofing has a certain texture on it that we can capture actually with reality capture. So then we get kind of down to what do we actually need to convey, what's important, how am I going to model this, and then formulate this on my plans. Even with a lot of BIM platforms, we take a finished floor elevation and we kind of apply that to the whole floor, that whole level, and we know that's not true as well. So you really have to understand that wherever that finished floor marker is where only that elevation is. You're going to start to deviate 1/100th of a foot, 1/10 of a foot potentially in different areas. So we've really proven how reality capture is effective as a great use case. So this has really expanded the market then in the past couple of years. So now we have drones and photogrammetry as another method of reality capture. We've got in the middle there is a low-level laser scanner. Next to it in the bottom is a kind of a mid-range, more expensive but more accuracy. And then even at the top, top right, we have your smartphone. Our smartphones are even being looked upon as reality capture devices. maybe not as accurate as these laser scanners, but we're starting to develop a spectrum of accuracy, where depending on what you need, depending on what you're trying to capture, that will dictate then the instrument that you use. Do I need a laser scanner with millimeter level accuracy? Can I use a lighter weight one? Can I use a smaller scanner during the project and start to track percent complete on a project? At SSOE, we utilize reality capture on almost 80% of projects. At the beginning, usually at the end as well, but we're toying with the idea of utilizing the capture devices during construction to start tracking percentage complete also. So now we get into that time element also with reality capture. I won't get into the details of it too, but there's a lot of different attributes you need to look at for how the data is captured, such as accuracy, density, how it was captured, what kind of technique and then how you register it and tie all the scans back together, and then what kind of scale. So I'll jump into more high definition laser scanning. This is a great cross section here that shows, if you look to the right of your screen, you can see actually the wires that are supporting this above ground utility. We're getting that much detail, and this is at 300 feet away. We're even capturing the snow on the leaves of this tree. And I cut a cross section because it's really difficult to understand and glean how detailed and dense this data is unless you can really zoom in and get incredibly close to it. And my next slide will jump into the differences of the data. So this is a project that we scanned and flew with the drone and registered to the same coordinate system. So everything is going to be the exact same elevation, but you're going to see that the methods with which we captured it will deviate. And the data right now is very difficult to distinguish between, but as we turn it on and off, you can see that was terrestrial scan data because all these capture devices are really based off of line of sight. So whatever it can see, it can capture. The drone, what it loses in maybe accuracy, it gains in scale. So we can capture the entire campus, a 20-acre campus, within 20 minutes. Whereas the terrestrial scanning is maybe a 4-hour job to only capture the points of interest that we need to connect different buildings together. So here we are cutting a cross section of it. You can see we turn off the photogrammetry data, we turn on the laser scan data, and you can see that there's definitely some noise, there's definitely some incorrect, inaccurate points there that if you did not know how this was captured and you just assumed that it was correct and just kind of use those as data points, you could be potentially designing something off of an incorrect data point. So I kind of glossed over it. Is anybody familiar with photogrammetry? A little bit, show of hands. About the same people, point clouds? Okay. Photogrammetry is the stitching of photos together to recreate a three-dimensional object or a three-dimensional space. And with laser scanning, you can glean a measurement from a single kind of laser shot. It'll shoot out and bounce back and give you an actual dimension. With photogrammetry, you need multiple photos, multiple shots per se to glean any information or three-dimensional data from it. So it can tell by the deviation in the pixels from different photo and how much the photo has moved that maybe this building height is 30 feet or so, something along those lines. So that was kind of the higher end level of accuracy for reality capture. The other end is really, if anybody's familiar with Zillow or Airbnb, they're utilizing reality capture, if you didn't know it, with 360-degree cameras or depth sensing cameras to really put the client or the user into the experience before they make a purchase decision. So they can actually experience it in VR or on their phone, whatever they need to understand what the space is going to look like when they're actually in it. And this is similar to virtual reality with, I think, architects and designers. We love that tool because we can really convey to the client what their solution is going to look like before it's even built, right? So you can iterate through it virtually, adjust and tweak before you even build it. So again, another example of how so many examples of reality capture are coming into the different industries. This is the overall campus, again, of that last site that we were showing. And this was, we're getting to the point now where clients want their entire campuses captured. Because some of these clients are so big, they have 4 or 5 projects going at once. They want to know how things are developing, how things are tracking and changing. We can kind of deliver them this 3-dimensional as-built. And instead of pulling drawings, PDF rasters from the 50s, we can begin to utilize this point cloud data and deliver this to vendors as they begin to work on different projects. And we can essentially begin to host this data also, because this is a living system, as Kristen alluded to earlier, is that this complex is constantly changing. I'll talk about a project that we did here where we had to maintain the plant's operations while installing some very large sugar tanks also. So just kind of one example of how our role is kind of all the data that we utilize to capture and to create our designs, we can continue to push that a little bit further into our day-to-day and then into the clients as these systems evolve. So virtual design and construction is something I want to talk about next. And this is kind of, it's not really a technology, but it's really, I would say, a workflow. It's an innovative use of the technology that we can leverage and begin to look at it differently. So this is a great photo, I think. If you can't tell, that whole back wall there is reality capture data. The darker beams there are actually is actual BIM data, structural data, and then we've got the different utilities in different colors. So we can begin to combine all these different types of data when we look to retrofit existing facilities or understand our existing conditions and our existing constraints, right? As architects, we like to know what our constraints are, and then we can kind of push those boundaries as much as we can. So we talked about BIM, and I think BIM kind of is lumped into that virtual design portion of VDC. At some point, I think BIM might kind of minimize all the technologies that we could potentially utilize, but it's just been the biggest buzzword that the news has really grappled onto. Again, that building information modeling, when we can jump from a CAD environment, two-dimensional environment, to a three-dimensional environment, we start to look at geometries and three-dimensional relationships. Then we can start to tie in metadata to it and understand that this is this discipline, this sizing, this data can then kind of transpire through and transcend the actual design and go into production, into fabrication, into so many other disciplines, and we can communicate this back and forth, again, kind of expediting those communication and feedback loops between all the parties involved. So this is that same site that we had to work on. It was a consumer food brand client where they had 50-foot sugar tanks that were 12-foot diameter, so very large objects that had to install. We had to keep the plant operational, so understanding the client's needs is incredibly important. If we can do that, then that really puts us into what turned out to be a confined space for this sugar tank, for this crane, for this logistical nightmare that really developed as we realized what our constraints were. So I've got a video that'll kind of show all that data again. And this is kind of virtual design and construction we see as almost the combination of all different techniques and tools and BIM and different reality capture data that can help all this data shine when you integrate it in different ways. So I'm zooming into the area right now, and you can see that we needed to simulate this actual lift install into place. And I like to think of the term scrappy BIM or scrappy VDC because it's very easy to overdo simulations, very easy to overdo BIM. That's why we have this idea of level of development, so we don't overdo what we don't need to do, right? We need to communicate what we need to communicate. We need to communicate what we need to communicate. You know, we have to understand what we need to communicate, and it can get confusing. So we need to keep our projects very, very lean, very expedient, and we were able to model it this way because we realized that this structure, nothing's going to be occupying the space during the installation of this structure. So we can keep it and model it as one mass, and from there we can begin to extract measurements and then say, well, where was that? What's the extent of that tank that's going to be installed? So then we can then measure back and say, okay, so that's where my crane has to be. So now I can position that to see, all right, how much space does that give me between conveyor structures and whatnot, and we can begin to simulate all the aspects of it. And this project, as we begin to simulate every different part of it, there was different issues with just transporting the assets into the site. With how big these things are, they required custom low buoys and different vertical clearance tracking and simulation on the actual site and getting it into the site. But because of all the combinations of tools we could utilize, we were able to really impact the installation method and say, I see what you're saying, installation crew, but we have reason to believe that you're going to be scraping this entrance here off the west. You should consider looking at the east entrance, or you should consider placing your crane a little bit farther back because the tank, when it comes up, is going to be bowing a little bit more than you expected. And we're able to actually take what we've used to design our project and actually impact the logistics and the schedule of the project. So I'm kind of doing this to compound upon all the technologies that we have at our hands. Reality capture data is really just this brute force of data that comes at us. Virtual design and construction, now we can look at combining this data with different BIM platforms, different drone platforms, any kind of information we can really glean to get what we need to communicate and understand for ourselves and for the client. So again, with companies that aren't able to utilize these kind of techniques or tools, they're not able to really prove their credibility or prove their workflows, I guess. And when you really can't justify your workflows that well, the client could deviate back and forth to other competitors. And as much as we like to think about it, it's usually the cheapest bid that wins the job. So when we can prove that this installation method is going to be the quickest, the most effective, we're going to have no rework, no schedule impacts. It's going to be done as expected. That really bodes well for the client when they're trying to understand that if we're the right people to work with or not. So to really kind of take us up a notch is artificial intelligence and how we can understand and glean any kind of insights from all of this data now that we're getting. And the big idea behind artificial intelligence is that automation and that kind of handing off to a different system that can do the same kind of thing for us, like generative design or parametric design, all the different derivatives of artificial intelligence. And and I think this is another example that people are getting kind of nervous about with this technology as replacing some of our roles. And I think it's very similar to the initial impact of the McKinsey report, where we're looking at construction. It doesn't want to embrace these different technologies because it'll replace the way that they're doing things. And we should look at partnering with these technologies instead of having them act as our replacements. When you look at generative design, what it really does is just massive scale that we can begin to look at and iterating thousands of designs potentially for a preliminary proposal of a project. Automating that, and then also that increases our opportunity then for more designs that we can then work through and churn through. For us to sit around on these designs and work maybe 2 or 3 weeks to come to the client and they say, what about this, what about this? You know there's always going to be changes with the initial designs. So when we can present them with more designs up front, we can speed up that process and begin furthering design and beginning structural, beginning mechanical, and all the other disciplines to really make this vision, I'd say, come to fruition. And we've even seen it, machine learning into scheduling and impacting and kind of looking at old project schedules. And maybe we can look at these past 40 healthcare facility schedules and understand how can we utilize that data to then affect this current healthcare facility we're going to be designing. Where can we impact the critical path? Where can we look at where we had issues previously? Let's try to avoid those for this project here. And also an increased level of detail and almost this granularity where they can take a fine-tooth comb and start to look at 4-hour chunks of a schedule and really see, and if we can begin to optimize and save maybe 20% schedule compression on a project. So all this data is really kind of the problem and the solution, I guess, where we have so much data coming up that it's really kind of fallen onto us, the designer, to really what can we do with all this data? How do we make it something that we can act on and kind of build our argument for why this is the best design, why this is the best method of install or the best method for project delivery? I think the client has communicated to us their vision, right? It's almost like a large game of telephone where I have an idea in my head, I'm trying to communicate to you, and by the time we get to the last guy, he's not really sure what we're even trying to build. So it's about keeping those feedback loops very tight and very I would say keeping the fidelity as we translate back and forth, because really what we used to be was we had no data at all, right? And we're supposed to stamp this. I don't want to put my stamp on this without knowing how these building connections are going to work together. But now we're in the opposite, where we've got a fire hose of data just bombarding us, and we have no idea how to parse it and separate it out and how to make actionable insights off of it. With reality capture data alone, we're able to parse that data, capturing one site. We can send half of it to the civil group, half of it to the architectural group, another half up to structural or mechanical to take their own separate ways and begin their designs with retrofitting. So I really see it as, we said, a live system. These systems are evolving, these systems are moving. I almost see it as like a design as a service type of role that architects or designers might begin to formulate or fulfill. I look at it as almost like a software developer where they are looking to create this custom solution. It's got to hit X, Y, and Z, these goals for the client, and we're going to prove to you why it's going to hit those goals. but it's also going to be constantly changing as soon as you begin to deploy that software within your organization. You're going to have hiccups here, bumps there, requires maintenance and adjustments. But it also requires scale and changes. So like a university, as the university is growing, as more students are coming into the university, as more majors are coming about, we have to scale in this area, scale in this area here. How can we do that? We've been tracking all these other environments. We've been tracking the movement through the campus. We can utilize all these different data points to begin to make actual insights for when that time has come, where we do need to expand, or we do need to put a new building here, or how can we retrofit this building to operate more like an auditorium or something else like that. So I see that design as a service role becoming more of our role with digital twins, with reality capture, combining it with any types of IoT automation type sensors too. We're not only gleaming this data, we're able to potentially interact with it and kind of predict it also. So I'll kind of wrap up there and just say there's some exciting times that we have coming upon us, and the data doesn't stop after design. We've been seeing it go into construction, into logistics, into the schedule, and even past with the actual client actually monitoring it and utilizing it. So I see this data not stopping, but just continuing at full scale. So with that, I thank you for your time, and we can again fail. Do you want me to turn this off?
Sure, yeah. Mic for you. Well, I think, thanks, Tony, and I think really you started to answer a lot of the questions that I already have, which is great, and I think that we can then get Pandish and Zubi in to get their input, because the first question that I wanted to talk about is this idea that with VDC, with simulation data, with digital twins, we're moving towards a situation where architecture, design, engineering, construction no longer ends at the delivery of a set of drawings or even at the delivery of a building, but has the potential for this kind of continuous post-processing feedback loop. And so how does that begin to change the role of the designer and the engineer in a kind of, if we're thinking about more about a building life cycle? And perhaps you can even just talk about what you've seen in your own experience, or as Tony started to kind of speculate on where that might be going.
Go ahead. It's a very loaded question.
Yeah.
And Tony, maybe you could just even reiterate some of the things that you've seen, or.
Yeah, we're kind of seeing the beginnings of it with, I would say, reality capture as kind of like the low-hanging fruit of understanding this digital twin. But the hard part, I didn't really talk about it, but the hard part is the data is so dense and so heavy that it's just brute data that you can't really handle. It's in the gigabyte range, going into the terabyte range now. And with the autonomous car industry has really latched onto this as well, with different LiDAR sensors that they put on, four on each car, that is scanning the environment to communicate to the car where it is, who's in front of it, what's in front of it, how to react to it. Those things are starting to create and capture petabytes of data, thousands of terabytes. It's getting enormous, and this is almost like a live Google Earth, I guess, with reality capture data. So clients are looking to have that same idea potentially, where what would that look like if we were able to kind of pull down these 3D as-built? How could we make that work, and how can we kind of disseminate that to vendors for future projects? So.
I think about it this way. So you have Gmail, right? You type up your email, and all of a sudden now you have this suggestive feedback. Like you type up something, or you receive an email, and it kind of prompts, do you want to say this? That's because you started the email, you got a response, and there's this continuous feedback. Like now it can sense, okay, this is how this person might answer this question, or based on the information that I received in this email, this is what the response might look like. So all of a sudden I said that to say with BIM gave the designers access to their data. you think of BIM, most people tend to think of Revit or ArchiCAD. It's more about the fact that there's a digital representation of the physical environment. And that opens us up to Google, it opens us up to Facebook. The whole idea of data, architects and designers and engineers are now exposed to what software companies are exposed to. Now the question is, how do you use it? Because one thing is to have the data source, another thing is to transform it, and in that transforming process, you're creating a cycle. Can what I transformed start to inform the source? And so now you have this loop where now clients, demands are not going to change, decisions have to be made, architecture, design, engineering, too many factors coming together. How can we bring all these, how can we model the problem, essentially, in kind of create an ecosystem where decisions are being made and past decisions are influencing future decisions. And so now you have a cycle. So, yeah.
So I would like to add to that a little bit because one, he mentioned something about the client always wanting the same things as in terms of expectations. But now we've become this machine that sort of like takes inputs and gives outputs. And it's a similar scenario that was 30, 40 years ago in the sense that we still are expected to provide things for the client, for the project. One thing that I've realized is that there is the early stages of design have changed significantly. You have to know a lot more now than you've ever needed to know. You have to start things with a lot of information that you generally start to discover in the process of the project, and it gives the impression that we are always the all-knowing, the all-knowledgeable. We are the ones that can answer all questions to the client and so forth. And in the process of giving leverage to the client's demands, and I'm not going to vilify anybody in this process because this is just the way that our discipline has evolved in the last 15 years, I should say, because I'm not going to count anything before the 2000s in terms of the stream of information that was coming through. And there's also this other thing where design thinking has changed and has taken a whole new meaning. Design thinking, I'm not going to even... Do we need it?
We need it for the
For the recording.
Okay,
recording.
here you go, guys. What I wanted to say was that design thinking to me has changed completely because now I have to strategize on how to design around a problem as opposed to taking whatever preconceived notions I had about design and history and knowledge from school and other experiences to now sort of create this problem that I have to solve. Because really, we are creating a lot of problems in the process and asking more questions than sometimes we're answering. And I wonder at what cost do we optimize everything to perfection to meet demands that are unreasonable, to provide something that is in this loop of information that is ever changing. Like, I think we are sort of taking ourselves out of the equation if we don't prepare ourselves with all the knowledge that we can get early on. I don't know if that sort of summarizes, I guess, how we used to do things versus how we do them now. Now we have to know everything right off the bat, and then everybody expects us to do so. There must be some trade-off to the aspect of, going to school, becoming who you want to be, really, and standing there and listening to me tell you that your job has already changed. Like, it's already different from 5 minutes ago. And I think by the time that you get there, my words are going to be irrelevant to you. Please.
That's great.
No, I like it.
Any,
No, I got one.
additional? Okay, great. I mean, it's interesting to think about a situation where design the design and the relationship to the building is kind of unending, and that we're just in that constant feedback loop, for better or for worse, that you continuously have a relationship beyond CA or even sort of follow up, but that we're retrieving information from a building that starts to inform other buildings, and we have that sort of perpetual relationship with the things that we've built. I think this one was a little bit inspired by some of the writing that Tony has done, but I think you guys touched on it a little bit in just the things that you just said. There's a quote from Edward Tufte that I really love, which is, "There are two goals when presenting information: convey your story and establish credibility." And it seems like in its sort of infancy, I guess it's not in its infancy, it's toddlerdom, we're understanding the value of these things as a communicative tool, as Tony said, and the data is giving us the credibility, but how can we better leverage it to convey our story? How can we manage data better? How do we better integrate it into the work we're doing to continue to use this as a communicative tool that doesn't begin to overwhelm?
I can go if you want. Real quick. I was just going to say that one example I showed on the screen was one I didn't show up, but that we had to, for us as the designer, to really impact the installation of this project. We were working with the logistics crew that was actually shipping this container into position, and they're using a traditional, almost like a yardstick method, where they have one person that represents one axle of this truck, another person that represents the end of the truck, and they're walking this physically in the environment, and they utilize different, presumed trucks, and we simulated multiple different trucks, in a couple hours, and we had to present that as, here's the model and the specs of the truck we utilized to simulate. We're showing that you're going to have issues when you enter from the south. Maybe you should consider the east, and very politely a communication back and forth, and then they went back out to check that, and sure enough, they did. They were hitting and they were impeding and hitting the different fence posts, different street lights, and all their information that we had simulated virtually, but. We've already designed it. We don't need to keep this data anymore, right? We just throw it out. But we were able to keep that data a little bit longer, I would say, and make it relevant.
One more thing that I wanted to add on top of the previous conversation, that he was saying, there's like this extension of ourselves now to. There's also an expectation, I think, to rely on the data to be accurate, number one. That's actually doing the right thing. The second thing about that is, do you really want to give up the ability for you to make the decision versus the machine? And maybe a third of that is, are we prepared, or do we understand it enough as humans to, allow the machine to do so?
Mm-hmm.
There's and in this case, I feel like we are at the forefront of this discussion with the clients. However, the clients also are teaching us a lot now. I'm not saying that we are the ones that were dictating. They're very much so giving us as much information in the same way that we're trying to mine it. They are being as transparent, and there's a lot more data that's coming through them. So they understand the stakes are high when it comes to this type of information, coming to us. And, the credibility, I think sometimes it's already built in, and they expect it to be met with the same type of expertise.
In terms of managing data, if I heard that right, is, as an industry, I don't know that this is totally new. Right? We went to school for architecture, engineering, some people here. And being exposed to data requires relearning. You have to learn there's a reason why there are computer science degrees, data degrees. If that's something that needs to be taught alongside the architecture, I don't know what that even looks like, but we're exposed to that, so we have to tackle it. I said that because the industry doesn't have a standard way of how data should be structured. We don't even collect data in a way that it will be meaningful for us as we talk about this cycle. So that's something that needs to start getting, I don't know if the word is standardized, but the system around the softwares we use.
Exposed.
Expose, so that our data actually works for us. We talk about machine learning, we talk about AI engines. They leverage data. If the data is not structured properly, well, depending on the type of engine you're using, if it's not structured properly, then you're not even going to leverage it anyway. So.
And I think the client really doesn't matter to the client really what we use to kind of bring their vision to fruition. You know, that's they don't really care if we use reality capture or if we're using drones. Is it going to save me money? Is it going to be cheaper? Can I get it a couple months shorter? Whatever tools we utilize is kind of up to us. But we do begin that stage though with this data mining, like you said, and that is valuable past just us.
It's sort of like a new concept, by the way. How many of you actually worked in a firm, architecture firm before? No? So at some point, you've had to engage with the new software I guess there's like one guy in the office that did the thing. And everybody went to, and he was the guy, even though he might have been like 5% in.
The BIM unicorns.
That's you guys.
Not just the BIM, but also the communication through parametric generative, software and stuff like that. That kind of sort of made those people superhuman, to the leadership or whatever. This is a struggle and kind of a consistent battle that we have to fight, with the older generation that are used to doing things in a different way. But at the same time, what we found out is that in the process of this negotiation about what needs to be done and what needs to, how we need to do it in the process, we've also found out that we become more conscious of the length of time that we have to think about a building after it is actually built. Like, for example, we have buildings now that are being tested for the first time because of new, because they're just built and the technology that was used was this new technology. And the test of time will actually show how they last and how they're going to be used in the future by some other person to use as a precedent study to do another project. But this also brings in the forefront all the stuff that we've learned from open source. Honestly, there's no way that we could have even made a foray in the digital technologies without self-discipline and self-study. There is no Linda you can go to, really. I mean, maybe now, but I still feel like a lot of the stuff that you need to learn on your own. Yeah. Mm-hmm. And the precedent studies now are creating this thing where we're creating more and more projects that are more digitally based, generative, parametric, BIM founded. All of those now are creating this exponential growth in what you see online to being used by people like him that have developed tools and like him that have written, to make the job easier for all those people that were never thankful for it. I feel like it's a platform to actually point this out. It's being recorded. On the other front, though, I feel like the knowledge base has been decimated in terms of, there's a lot. Mitch, which works for us, he has written some tools too for Revit. And it just makes the job easier for everybody else. And I feel like there's a lot of people that have done this, and without that major work to get us to that point, none of this stuff would have ever happened for all the other buildings that are coming in, in the next 5 to 10 years coming online. But those buildings continue to gather data, continue to be connected. We work with Prototype, we work with DaVita dialysis, clinics, but they are sort of like centralized systems for all their mechanical. They run everything from like a central headquarters, and this is facilitated mainly by BIM and nothing else. You know, like they want this to work this way because they can shave, 10% here, 5 here, 1 here, and then at the end of the day, that makes a big chunk, of money and resources and time that people don't have to spend.
Yeah, I think you touched on too the major of architecture, the role of architects is like with what was his name, Mitch? Yeah, I mean you've got some computer programming background. You've got some do the architects now have to be looking at doing a minor in computer programming to start utilizing tools to automate some generative design tools or start attaching structural members as you begin to facilitate out these designs or bring them out? What is the tool? I mean, what is the tool you need? There's so many that we can begin to consider. I would say, it really depends. And with all the scripting tools out there that are becoming available, I think it depends on where your career, where your interests are. But there's definitely opportunities for growth for a lot of these deviations in the major.
I'll add, it's interesting to say that because WeWork, do you guys know WeWork?
Mm-hmm.
Yeah, so they just put out a job description for an augmented design intern. The job description is shocking. It's like, on one hand, you have what you need to have as an architectural intern, and then they require C++ and Python and like machine learning experience. Who are you? Are you guys ready for that kind of job? But that's what demand. Like that's the demand. That's what they require now to get to where they want to get to. And so it's not like this is future stuff. This is now.
It's actually something I was pondering driving here too. It's like, what are we talking about? Are we talking about BIM as the future or BIM as the present? I think it's already here. It's been here.
It's been here.
It's now, and and there's also this danger that we will somehow be priced out or worked out of our profession through this type of software, BIM, information management, and all that. I feel like maybe there is a shifting and a transition of our field, and those that don't make it, and this is just how every other job has been transitioning to, right? I mean, what happens to those buildings that were built in the 50s? We're still trying to rehabilitate them, and we're trying to use them. I don't think that there's this whole repertoire of architecture that now we have to go back with the scanners and scan. We have to, we're not just like raising, we're not doing a carte blanche and then starting over with this new technology. Yeah. We have to engage with the past, and I feel like, as long as there's a need for that, there's always going to be a need for architects to make that decision. And I'm not saying just architects. I've kind of gotten sick of that word, to be honest with you, because architects are also in information management. Yeah. And they were architects before we were, and networks and systems designing. So.
Yeah, I think it's just the architects just didn't know the amount of data that they needed to be in or had at their hands too. We're beginning to be those keepers of the data.
Right. I mean, it seems like there's a potential for the future of designers to be data analyst, and that data visualization is sort of the future of design representation. Maybe not one and the same, but certainly a lot of overlap. To your point about needing to be able to manage that data that's meaningful, and it seems like the best role to determine what's meaningful, right, are the designers, right? How's the data meaningful to designers or the designers themselves? You were going to say something.
Yeah, no, I was going to say that we're actually. Designers are in the best position to actually handle data. And you think of the creativity that we have, and we're bringing all these different systems together. It's just an amazing opportunity right now to be a designer, to leverage those tools.
Right.
Going back to,
that same article that I was referencing, the Philip Bernstein article where he's talking about kind of what's next, and he mentions that he thinks there's this sort of potential for a wave of rationality from data-driven design, but then cautions against, and I think this is right, what we were just talking about, cautions against the potential for data to overwhelm the value proposition of being a designer, which is to have insights and perspectives and to advance ideas, or to your point, to be the ones making the decisions. And I think there's a potential to see data when we talk about AI and the tools and software that manifest it, that those tools, the belief that the tools then become the intelligent component and the designer becomes the dumb machine, right? And that's not the case, or that's certainly not what we want to be the case. So maybe.
He probably wants to elaborate on this because we fight consistently with one another about this. I think last week I yelled at him. I said, well, you can't code yourself out of the problems. But he's right, and he was right for that specific thing. You can always code yourself out of anything, and I feel like there is a need now for the new generation to start coding right away. And to understand a new language, and without forgetting how to communicate, obviously. One of the biggest regrets I have as a designer was that I never fully engaged with or as an early adopter of these technologies, you know. And to a degree, when I was in architecture school, I had this, desire to kind of be techie and savvy and all that, and that kind of sort of bred more desire to learn, generative design. But at the same time, it also sort of made a monolith of the design process. What it is now, it's like you are the fabricator, you are the designer, you are, the manager, and also because we have all these tools, somehow we think that we need to do all of those things together. And as a sole user. And that's where the misconception is about information. It requires still a huge number of people to work together, still even more so and more efficiently to work with these tools. I think, digital vernacular that obviously Ralph have put together showcases this very notion of this untrained level of design. But I feel like we're all untrained until we try it. In this case, the tools have given us this impossible task to design as if we know everything in advance. BIM, Grasshopper, Rhino, whatever the 3D, the connection of the three together, Dynamo, all of those are just we're scratching the surface as designers on those things. And I don't think that that's our job to learn those to the efficiency that they need to be learned or the depth that we need to delve in. I feel like we're just testing the waters. We're experimenting consistently. And time is running out for us, so that's why the new generation has to start very, very early, the coding, the writing.
I think the biggest challenge is that our competition is, I keep saying it, Google, Facebook, because when they decide to pivot or diversify, and they start, Apple just released credit card. It's a tech company that's going into finance, something. What if they decide, hey, you know what, let's figure out how buildings are built. It's data. Now they can start exploring. They have the budget, they have the manpower, they're just gonna keep going. So that's the reality. We can't even fight it. It's not something that we're gonna have to fight. It's just what's gonna happen, right? But the question is, how about we reevaluate what our value is as designers? And it shouldn't be designer versus machine. It should be machine and designer working together. So at Inform, we see like the computer as a teammate, not like, oh, this is gonna take my job. Yeah, there's some tasks that you didn't go to architecture school to place 50 doors. Like, it doesn't make sense. Like, that's not how you feel. So if you can focus on what I need to focus on, what is my value proposition, and let the machine do what it's better at doing anyway.
And it's funny how that's evolved too in that conversation. The projects that we deal with now, I don't think a lot of discussion goes into like, oh, how we have to place all these things, we have to do, there's this much to do. I think the CD phase of the project has changed completely, and we don't even talk about it anymore because we know that it has to get done, and it will make tools to go faster than it ever was.
I think that's as you work with clients and as the project develops or the design develops, they always ask for drawings. And we're going through kind of a learning curve with our clients where we're actually going to be using coordination models instead. And we're going to talk through these design issues and these clashes here and here versus delivering a weekly drawing set for progress. We're going to deliver weekly models. We'll worry about the drawings at the end. That's the contractual part. We're going to worry about that when we have the design set and ready to go versus wasting time on generating drawings, cutting things different sections and whatever it might be.
Like we worked on the Providence Bridge. Our deliverable was a model. We had drawings, but the drawings were useless because it went straight from the model to the fab shop and assembly. Who needs drawings at this point?
Mm-hmm.
There's a trepidation about that, right? Like, do you want to give up your model?
Ownership. Who owns it?
Yeah.
And that's, architects have been struggling with ownership, I think, for a long time. And we still don't own anything, to my knowledge.
I mean, it's getting similar with reality capture too.
Right.
Reality capture, like, do we have that right? Yeah.
Our server is full of models, I'm telling you.
Oh yeah.
I don't know if anybody's ever going to use them. Ever again. Maybe.
But you have them, right?
We do have them. But that's the. I mean, it's a joke, but like we've gathered information. Maybe the next phase is how do we sift through it properly, or maybe we use artificial intelligence to sift through it for us, and machine learning.
I think I posted something in our office tech group. Is how there's an AI algorithm that creates music and responds to like based on how you're feeling. Like it even has 5 albums on Spotify, and it got signed by Warner Brothers.
Who signed the papers?
Yeah, that's a good question.
Oh, exactly.
But it's an artist. Like it's the algorithm itself is signed to a music label. So it's now a question of what does that look like for architecture? Like, can that ever happen? I've stopped saying never.
Well,
I've literally stopped. I don't know.
I want to branch on that a little bit too, because I think we're dodging one of the phases of construction, which is the final phase of litigation. And nobody's gonna take an AI to court because AI is not going to pay them for the rework that had to be done. So there's always going to be that level of QA QC of this BIM data, of the way it was built, of the AI built it this way, but you stamped it, you put your seal, right? And AI is not going to take the ARE exams for you, right? Or take it themselves. I bet it could pass them, but it's not. It's like there's that accountability instrument we have in the industry.
We're also very far away from like a complete handoff. Yes. I don't think this is not going to be a problem for us. And
Generations.
Yes.
A lot of people have sort of thrown that in there, like, oh, they're running you out of the office, really. But it's not the case. And as long as there's going to be a desire to make new things and to innovate, we're always going to be there. In terms of like digital fabrication, which I've sort of dabbled with a little bit, I can tell you that it's an enormous. And I'm going to parallel this with what's happening with YouTube. A lot of people are serial YouTube watchers in terms of instructable videos, right? Instructional?
Instructable. It's fine.
Yeah, right. So there's like an instructable.com website, right? And everybody just kind of watches continuously. And there's this perpetual like information gathering without actual production. And I feel like digital fabrication has empowered a lot of people to start to make things as a single user without having to work with others. That's a false, assumption, I think. I've learned more and more that as you get into these software and this type of technology, you need more and more others to work with you in real time to make this happen. That's why people are important still. We're not going to kill them all off.
Still.
But yeah. Sure.
Do you want a mic?
Can
Here.
you give her a mic?
Yeah.
So I know earlier one of you guys mentioned how we could implement some kind of like learning into when we're going into architecture school, like how we have our studios, but then also adding in computer design or programming so that we could also have that understanding into going into this. But how do you find that like little, what do you call it, like barrier between architect and construction industry and finding a way where they can understand how you're giving them the data? Does that make sense?
How can they depend on it, or
Yeah, like how can they catch up to our knowledge of it? Because I know the construction industry is like, they're so used to us always giving them the plans like 2D, so then if we're starting to like process that, so then how do they catch up?
I think that's, yeah.
we wouldn't even switch to metrics.
Real life experience. I completed a project recently, and I know that the average age of all the construction workers that were contractors and stuff was probably like in the 40s and 50s. And with some that were, still welding up there, and they were like in the 50s and 60s. And I feel like the reason why there's not a lot of young people in this field is because of various factors, in the economy and what happened, the recession. Everybody went to college, not trade school and all that. But I feel like we're going to catch up to that. That barrier is not going to be as bad, I think, in terms of the communication and understanding of the construction part of the design than the designers would have. So I think that we're like maybe a few years away from that to happen naturally without us really having to push for it. It's just that right now we're in like this weird situation where a lot of the older generation is still there. No new blood is coming in, to supplant the construction side. And I think we're going to catch up. It's happening in an organic fashion.
So I was going to say there's also heavy research happening in robotics in the construction side. I'm just going to put it out there.
You guys have one, I'm assuming.
Yeah. And most of the time, the reason we need drawings is approval. The approval process is the worst. It just needs to change. And then if it's digitized, you kind of skip that process somehow. I don't know what that looks like. I don't know. This is the argument we were having. But yeah.
I think that's interesting too. I think there's a big discussion going around. Can an architect stamp a model? Can they approve a model for design? And I think that's a big kind of rabbit hole too, because it's the plans are contractual. Whether you've modeled it or not, whatever's on the plans is what the builder I'm going to build to. And if you modeled it wrong and I build it that way, it's on the plans though, so still a barrier.
So I have a statement and then a question that actually relates to what you were just saying, Tony. I think the statement would be that I think we could have this panel discussion in every department in the university, and we would be saying the same theme would emerge. So business schools are saying, oh wow, how can we manage our data? Medicine isn't, the data is enormous.
That's a nightmare, right?
Yeah, it's a nightmare. Obviously, the auto industry, I mean, every industry in the world is having the same conversation. This is just our flavor of it. And the reality is that, at least in architecture, you know, that all of the thousands of years of knowledge that we have in architecture still is out there that we have to understand to implement the data and decipher the data and its relevance. So that's a challenge for a unique challenge, I believe, for your generation. I think the challenge for my generation was the fact that the personal computer was upending the production of CDs, which at our time seemed enormous. The challenge for your generation, is like, how do you deal with the enormous amount of data? But I think it's a huge opportunity, and I think Zuby's absolutely correct that, you know, it's not, your competitor isn't the firm down the street. It is Google, and that data that's on your server, Pandush, with all the buildings in it, has a certain level of value to it after the fact, but we don't know exactly where, and as you said, we don't know what that looks like or where it's going. So it's a matter of time. They've cataloged almost every street in the country, and wait until they've cataloged every building in the country, and I don't think that's unreasonable. So that's the first thing. The question is more of a practice one, and it's my own question, because I haven't had experience with this, and I was really interested, Tony, in the scan that you showed of an existing building or even a proposed building, I'm not sure, as built, of a floor. And that floor is assumed to be level. And one of the things in my own experience in digital fabrication is that we design these components, these digitally fabricated components, and the assumption is that they're going to sit on a square, flat floor, and they actually are made incredibly accurately. So we actually were victims in several projects that I worked on, and Ralph helped me on one of them, where we made this like kind of perfect thing that then had to fit on an imperfect world. And so when that happened, it didn't work anymore. And so we were like, wait a minute, the world's not square? And so you showed a scan of this floor that has these dips that doesn't surprise me at all. How then, when you bring that back into the office, this is the practice question, how do you work with that, like from a construction, like I'm thinking to myself, like, how do I put the datum points on there? Is like my whole BIM model like shifting over, and where do I find the moment of square? Because the tile will probably end up being square that's on the inside of that wall. So where do I, like, are we in a position now with, we have so much information that we're actually having to then model in those moments of what I would call improvisational moments where a craftsperson squares a wall to something they know isn't square? Like, how do we deal with that in the model? Like, I don't, like, if you sent me that and you were like, okay, Jim, here's the building you're working in and nothing's square, but you still have to design to it. How I don't know how that's done, because I always like worked in a vacuum of digital space, or with pencils that didn't know they were square or not.
I think it's all contextual. It all depends. You know, there's so many variables. Even when you think, like when you were talking, I was thinking the word kept coming up, the idea of tolerances. Right. You know, like even though I've proven that this wall isn't straight or is 89.8 degrees, you know, instead of 90 degrees, what do I need to communicate in my BIM, in my model? I need to communicate that start point and that end point. And so it's about understanding what you need to communicate. I was talking with a client that was looking at recreating these old arches in a you know, an older building. They laser scanned it and realized they weren't you know, exactly like what are the French curves that we used to use? And I haven't used them in a while.
Arch, yeah.
but you had to. Well, they were like, well, do you want me to recreate it as I just scanned, or do you want me to kind of interpolate it? You know. And I think it all depends on the use case too. It's not what you think it is.
It just seems to add a level of complexity that I'm not sure is adding to efficiency. I guess that's my concern.
Exactly.
And I just don't know, because I haven't been put in that situation yet as a designer.
We will laser scan stuff that we do need some of that millimeter precision when we're looking to extract between, we're not always doing architectural retrofits. We're maybe scanning transmission lines from different power stations. So we need to understand where the end of that conductor meets that wire to start. And traditional survey, you're trying to put a rod up there to try to measure these things. How else are you going to capture that? But when you can capture that amount of detail, you can understand that the temperature affects the compression of these insulators, and then the slope as well, and then that then dictates the sag. And so I can understand what kind of load and what kind of, I don't know what the electrical guys are looking at, but they can pick out the differences in the compression and then the temperature of those insulators and then the sag off of them. So sometimes you do need that amount of data.
Great.
So.
That's my question.
To that, I know not to give too much away because we're going to be presenting the Ferrari
next week.
dealership next week.
That was scanned, for sure.
That was scanned, but we had a computational model that responded to point cloud. So we know if they sent another scan, we would have the facade kind of adjust within the limits that it needs to operate.
And I believe it was an error.
Yes.
In terms of construction, they built it the conventional way.
Yeah.
And then we went back in after the framing was on, and I think we have images of that in the presentation when they scanned the whole thing again and they came back and we saw that there was like I don't know how many inches, but that's problematic when you have a double curve, facade and all that. So it became invaluable and saved, I don't know, hundreds of thousands of dollars probably, and litigation. It's awesome.
Take care of it up front,
All right, so I'll start with the question, and we'll walk it back a little bit. But how do we convince clients of the value of design? So as we're moving and we're getting more efficient, and we're able to run iterations, and we're able to algorithmically pick the best of those iterations, right? And we see that happen in our design every day. So we're losing time in design schedule. As this gets faster, where the winning clients or the winning jobs are going to be the ones that go fast. So how, when we run into an issue that it can't really be solved, like using simulation or using algorithms or whatever it may be, whatever slows us down, how do we still convince clients that are used to seeing this accelerated pace that there's still value in in-person engineering and seeing it or value in design itself?
I think a lot of that comes down to the definition of value and then whose definition of value you're talking about. So the client's definition of value and making sure you have that alignment, right? The alignment of value. Well, okay, I see that maybe this client may not need maybe this reality capture or maybe the parametric design work that we're doing. But others definitely will need it. That's going to prove your concept correct.
I mean, VR, everybody loves it. Now it's like it's almost a requirement. They want to be seeing these projects from the inside. They want to see the scale, more match up to. We all produced renderings 5 years ago, 10 years ago, 30 years ago. They were doing watercolors and stuff. Now, it's the entry point is a completely modeled building with some textural materiality and all of that type of quality added in, and then they have to come in there and just be like, wow, I hate you now, now I have to find money to do this,
I was to say, that's before you even begin design.
Exactly.
You have to wow them before they even give you the bid for the job.
Which it's sort of in that loop of when do we really start with things? Now we're starting for further ahead, than we've ever done before. And they do see the value, by the way. They do see the value of this because it's dollars, unfortunately.
Okay, so I have two questions, but if we're running out of time, I can pick one. So my first question is, I hear a lot in the architectural practice that we are running out of people that are skilled people, they know the trades. Do you think that technology in construction will help sort of fill that gap? And the second question is, on the presentation, you talked a lot about data-driven design and photogrammetry.
Grammetry.
Yeah. So I was going to ask, now we are at a point where we have to consider sustainability more than we've ever had to before. So how will advanced technology help us? Is it going to be additive manufacturing? How is it going to help us address that issue?
What was the first question again? I'll just start at the beginning.
So the first question was about technology being able to help with the lack of skilled people in construction.
I think those two I think kind of tie together a little bit. I think we're all familiar with Autodesk. One of the pilot programs they're working on is this manufacturing in a box type of factory in a box type of thing, where you can ship this two-armed robot that will 3D print whatever kind of part is potentially needed at the moment. So I think I see a lot of commonalities and use cases there for sure. And whether it's cost effective yet is, it probably isn't, but it's the idea, improving the concepts too. If anybody else, I was going to try to think of the second question too, then the sustainability.
To add to that, it will get cheaper.
It will, yeah.
That's just how it will get cheaper.
Mm-hmm.
And then it becomes norm. Then we take it for granted.
Did anybody see that video? There's this, it was passed around. No, I think the one with when the mason was wearing the
VR.
Oh, HoloLens?
and then he was like,
Yes.
you could see the bricks as they would have to be placed, which now the robot can do accurately.
Yeah.
And I feel like that's where we should probably start. Yeah, it's like that's how you train somebody to do those. It's actually to see augmented reality of what they needs to happen, and then by sheer muscle memory, then they will become better at it, and kind of bridge the gap of knowledge.
I think what you're saying there too is good to differentiate between like additive manufacturing and 3D printing. It's very attractive because it's just one material and it just goes and follows a routing mechanism. With there's another company called Fast Brick Robotics, which is taking existing materials like bricks, like cinder blocks, and is just using different machine learning and computer vision techniques and laser precision to just start placing the same blocks that a normal mason would. And so that's definitely a little threatening too. But it's hard to compete with it when the robot can start feeding cinder blocks into the arm and not have to come back and forth. So it's definitely, and I think that's going to save costs. It's going to save time too, and that's ultimately going to save a lot of the sustainability metrics you're looking to hit too.
There's one piece of information that has come to light recently. I think it's when they said that in the 70s we were producing, in manufacturing, automation actually has reduced the workforce to 30% of what it used to be, but produces 3 times more as what it used to produce. It goes to show you what it did to manufacturing, and I think that's going to happen to construction, and it's going to happen to drivers, and it's going to. So it's a retraining now that we have to do to everybody. This is just how we live. We want to live this way. We made this. We have to work with it now. Is that the final? Oh, one more.
Okay, so I have a next question. At this point, you're saying that BIM is becoming this big revolutionary idea in architecture. So do you think BIM would become its own degree in architecture, or would it stay within the architecture program as a certificate as it is now? Because as of right now, there's 4 classes, and you get basic knowledge on just a few programs. I think it's Revit, and I did CATIA over the last summer, and I'm already halfway down the program, but I feel like I haven't learned a whole lot. So do you think it should be more in depth with more classes for just a certificate, or do you think it should be its own degree program?
I think that I like the question because I think BIM is just a tool. BIM is the mechanism. It's not the industry. We still need to prove that when I use BIM, I can create the best design for the client for this solution, and I can communicate it and distribute that information much faster than traditional two-dimensional plans, maybe traditional email or other methods too. I can expedite the project with this tool to create the same goal that I had. Like, I think our goal as designers is still very similar. We're looking to deliver the same solution, but we're realizing that we're using so much data that we can begin to pivot and begin to keep our solutions and our almost our hypotheses for our solutions that much more accurate, that much more like accountable or credible too.
Yeah, the what stays the same, the how is changing. You know, so you can't really separate the how and make it its own thing. It's part of what we do.
The whole degree thing, I think, will change completely. And I'm sorry, I mean, the fact that we have a education system that teaches us in a certain way now doesn't mean that that's how it's going to be, and it's already changed. I mean, I don't know about you guys, but there's people already starting to not go to college. Sorry, LTU. I mean, you know, I know you guys want enrollment up and everything. This is the case. Is like, how will institutions adapt into teaching, you know, the next generation of the workforce?
Instructables.com.
It's
out.
but we're seeing this, that, you know, universities are reducing the footprint that they have.
Not relevant.
Right, and you know, like, I don't know how much some of those older institutions with a lot of gravity and gravitas and, like, you know, history, I guess, and you know, Ivy Leagues are going to really matter at that point. You know, because they offer like a BIM degree, or do they offer an architecture degree? I think they will be offering the same degree and the same things that they offered before, and I think some of the tools being used are going to be very, very different to teaching people. But I feel like the philosophy has not changed a lot. You know, I think we're still, you know, doing the same thing that we did 5 to 10 years ago, but I think we're seeing a change now in which people are learning themselves and sort of cutting out the middleman that used to be the institution. It's a very scary thought, I know.
So that's, I'll say that's what data does. If I have access to information, it's who is giving me that information, because what you need is information, right?
Mm-hmm.
So
I think that's also why we worry about who we hand our models over versus our plans.
yeah.
You know?
Maybe selfishness as well. Has to be a little bit.
Yeah, man.
Well, I guess just a few more comments, and I'll try to be as brief as I can. So great conversation tonight, very exciting, relevant topic. So I guess maybe even picking up off the last comment. So as we, I guess, train architects in school or introduce students to architecture, I don't know how the students feel about it, but it seems like there are more and more demands on them to be jack of all trades and actually demonstrate high skill in a variety of things. Mm-hmm. And I don't know where we reach the limits of human capacity, but it seems like there's certain aspects of an architect's mind and actions that can't be duplicated in other disciplines, and I would hope that we would also remember to retain those unique characteristics. I think you were talking about that maybe earlier. But I'm also then wondering, just like architecture as a discipline or the practice of architecture, the profession, if actually we have to stop very quickly thinking about firms where like the architects are supposed to be in charge and the prime drivers, but rethink the whole idea of these new collaborative entities where you're not just getting mostly architects together, but it's a range of people with various expertises and perspectives. And I don't know, maybe Inform Studio is a kind of crude model of the future of practice where it used to be just architects, but then you decided, oh yeah, we actually need some people who know expertise in just technology, not architecture. Oh, and actually it'd be a good idea to bring some engineers into the firm because they know something that architects don't know, and they're all about, you know, you're all together working towards the building production. So what's the next step? I guess the next step is the whole modeling service side. It's also construction, so you'll actually be doing the construction. I know some firms have already branched off to have a construction arm, or maybe that's just the whole entity. And then I can't wait to have architects or architecture firms take back the control of real estate exchange, because real estate agents get paid as much as we do, except they don't do anything. And why did we give that up, 75 years ago? I have no idea. If we have the model, if we're in charge of the building, we should control, well, I don't know, control is a bad word, but we could be a part of that engagement. So we would need people with real estate expertise also working at Inform or what have you. So that's, I don't know, I guess my big, expansive, wild thought about we have to change how we understand what an architect is or how we train architects if the future of practice is in these collaborative units. That's what Google does, Facebook does. They get a bunch of smart people with very different backgrounds all working together for similar objectives.
We have to start thinking like software companies.
Yeah, well, that's what I'm saying. Yeah.
Essentially,
Yeah.
it's what is your client pain point, and how do you solve it?
Okay, so here's a bigger question. Sorry to interrupt, but it gets to your environmental or sustainability question or whatever you want to call it. But you're talking about productivity going up, right? One worker produces 3 times more than they used to, right? Well, 2/3 of what they produce is just useless crap. It's like we have more and more crap, and we have an insatiable appetite for more and more energy. Where does the energy come from? An insatiable appetite for new stuff. At what cost to the environment? What is actually sustainable?
That's a good question. That's a very good question. What is sustainable?
Yeah, and I would actually like to see, rather than things become more complicated, dealing with complexity through making things more complicated. How can we deal with complexity by bringing it down to greater simplicity, or actually working with what we need, not necessarily what we desire? And I'll stop talking now. Too much.
There was a period maybe in the early 2000s where we were seeing a lot of that crap generated, which was this molar, toothy looking architecture. Calatrava contributed to that a lot, and many others, I think, and as a precedent setter for what architecture should look like in a visual representation of something that didn't really exist before in that fashion. I feel like we've already backtracked. We've gotten to more of at the core of the idea of BIM and information, where now we don't care as much about the most outrageous looking thing that we can produce. It's more of like how much of it, it's like the secret that we know that that building holds after we do it. And I feel like that is super important to acknowledge that there is so much, the buildings are smarter, we are smarter for it, because we're building smarter buildings. There's a lot of crap out there, absolutely. I think Frank Gehry agrees with you.
And speaking to the whole
Kudos to that guy.
real estate side, I would say with Inform, we actually help the client optimize their pro forma.
Yeah.
We have the design, you have your numbers, we would figure it out, like what is the best value for your dollar.
Yeah.
That's on us. The question is, where can we take it to from there? But that's how we have to start thinking, right? Where is the value proposition? Where does it lie here?
For certain projects, we increased by 18%, I think.
And are you getting a higher fee for offering more service?
I will not speak to that.
Exactly. But yeah, it's something now. Do we have that as a new service. I mean, that's how we present it. As to what that is, I don't know. But it's starting to rethink practice. Like, okay, we can have that value add. You pay for it. I mean, you know, so you start to rethink what the value proposition architects present.
What?
Sorry, we've taken over the cost estimating too, by the way. So no matter what people think, we need estimators now, we are doing it.
Yeah.
And, you know, to our fault or not.
Well, I think you talked about like the design portion, and we talked about earlier about how we need this bomb diggity design before the even proposals are out, type of thing. How can we afford that? How can we produce that? We've definitely been seeing the rise of these CAD or BIM farms coming out, where you get solicitations all the time. Where we'll you've got the design, you set it up, we'll start churning it out for you. We don't need to be placing 5 doors because we know where they go. They should go this way. We can kind of hand that off. I was going to tout on your first kind of question was this jack of all trades type of thing, and where does the bar stop? I think that's I think that goes back to the individual's goals, and kind of what Punish was saying, where you have to self-learn a lot of this too. So I got my degree in architecture and civil engineering. And then as I got into the workforce, I understood that, well, if I want to do this, I need to learn a little bit of this software so that I can demonstrate the value here. And in the example I showed, it's like, well, I'm not going to have somebody teach me how to model this in Navisworks. I'm going to just do it myself, learn it real quick, and I just have to, you kind of piecemeal together what you learn, and you become this sort of amalgamation or conglomeration of tips and tricks and stuff,
Yeah. Well, and we all have to be jack of many trades. The question is how many trades, because you can never be jack of all trades.
Can't be jack of all, right? Yeah.
I think we run out of time before we ever became that. But I mean, I always looked at our education not as a means to an end. I know you're not going to say something different right now. I always looked at it as like a continuous journey and process.
Yeah,
and I feel like, right,
Yeah.
and I just so happen to be an architect, but does the licensing exams, do they really give me the test of what an architect is? I don't think that's the case. There's like multiple ways in which we can.
Certification doesn't equal.
Well, I was gonna question you there, because I didn't take my AREs, but from what I've understood about the AREs is that a lot of it is making sure that this is a functional system and will stand up to the test of time, will be safe, and will be I would say stampable, so that. But I don't think a lot of the architecture exams are. You can correct me if I'm wrong. Are they looking at who's got the best design, or what's
It's the litigation component.
Exactly.
Yeah, it's exactly.
Exactly.
But and to the core of everything, how are we being tested as designers, in the field? I think that's why we're preparing ourselves to meet those tests, not necessarily to be certified. I think that we have different architects in our firm doing different things.
We got a student question here.
I know we've been talking for the past couple minutes about jack of many trades, and then and design turning into a collaborative effort between multiple people and specialists in different fields. And I know from my work as a subcontractor, with a glazing subcontractor specifically, when we get BIM projects in, it always turns into this highly collaborative effort with the architecture office. And I noticed that that's the biggest thing that BIM provided as a subcontractor is the communication. Is it facilitated communication between the different fields and specialties that need to interact. And it's essentially just a tool for bringing everyone together and on the same page for design. And part of my question really is, right now, BIM is slipping into the mainstream of the tool that is used for coordinating between offices, for the offices that are using BIM. But I'm really interested to see how that continues to develop and how it incorporates with VR and AR both in the field and in design. I have this funny vision in my head of one day working in an architecture office and designing in augmented reality and working real time collaboratively with the stonemason or with the steel manufacturer, and essentially parsing out parts of the design to the different fabricators as part of the BIM and AR model. And I know that's sort of how it's done now, but
Some of that is close, I would say. A lot of like the HoloLens competitors are putting some different type of depth sensing cameras on their helmets, but you know, you're not going to be walking up to a wall and scanning it with your head. You know, you can, you know, but that data can then be streamed through the internet back into the office, where somebody can then overlay some different BIM, you know, prefabricated models if they need. You can then overlay that back out to you who's looking at the wall and say, oh, that looks good, checks out, send it, type of thing. So I think those workflows are being vetted.
So just a real quick comment. I think I'm looking around the room. I think Ralph and I and Eric, we remember when CAD was a tool. And so, and what I mean by that is, you know, CAD was this revolutionary thing, but it essentially was a drafting table and a computer. And it was isolated. And it produced the same things we did before, but at greater efficiency that were put on paper. And there's a great book called Builders of the Vision that I recommend. But in one moment, there's something said that struck me that said it's not a tool, it's an BIM is not a tool, it's an infrastructure. And so it's less like a hammer or a saw and more like the electrical grid. And I think for me that's more of a shift and more of a change than what Eric and Ralph and I went through when we switched to CAD, because the output and the input was essentially the same when we switched to CAD. It was just faster and more efficient. What's happening now is the inputs have changed. There's multiple, like multiple, like infinitely more inputs, and the outputs are being questioned. And who owns it? What form does it take? Is it digital or is it paper? Who do we submit it to? Where does it live? And where does it end? And that's the big change. It's not, I mean, I know we talk about the students need to be jack of all trades and learn the tools. You guys are going to learn them. It's going to be okay. You know, it's going to be okay. The question is how, and I think to Ralph's question, like, what are we going to own and what are we going to take back? What are we going to capitalize on and how we're going to use it? And it does behave more like manufacturing than it does building, even if we build it, as Eric says, once and in the rain. And so, but it's still behaving more like a manufacturing process. And unlike the big three who own a lot of the car production, we have a lot of offices out there. And if that means we're going to get consolidated into Google, I don't know. But I do know Amazon just invested billions into a prefabbed, sustainable housing company. Now they may be willing to lose all of that, but it means that they're serious. Mm-hmm. And so I don't know. I don't know these answers, but I know it's going to change. And in the end, we're the ones that have desire and make decisions. And we're the ones that are trained as architects that I think will be highly valued, but I don't know who we're going to work for. And I guess I say all of that to maybe switch from as you mentioned earlier, Ralph and I wrote a book, that whole section called Tools, but now if I wrote it again, it would be infrastructures. And so it's just something to think about. That might be it.
All right, great. Yeah, I got one. Well, yeah, I think this has been a great discussion. I want to thank our panelists for coming out. Really insightful. A lot to take away from that. Certainly, I think, as I mentioned before, we're talking about new ways of thinking about design and technology in the industry, and it's a great conversation to be having. So thanks everybody for coming. Thank you again.
Thank you very much.
Round of applause again for our panelists. Thanks, Jim. Great.
Thanks, everybody.